Christos is on auditorium, it means I can start. And by the way, he has great, with Błażej, they have great presentation today evening, which is about something completely different, but it's great. So, first of all, I will show you a couple of things about myself. So, I live over the lake under this mountain. It's a beautiful place, and yeah, I work for a company called CSS Insurance. I am developer, wizard, and architect. I mostly work with Java-based technologies. And if you, for some reason, like skiing, mountain bike, generally you love mountains, you like to swim over the lake, yeah, you like all that stuff, yes, we are hiring. And there is one trick about it, you need to know German. And there are people I know that think life's too short to learn German. But there is a trick, a hack to that, life hack. I can show you. Who knows this map? Air quality index. So, you know, I won't just comment it much, but just take a look at the place where I live. So it's right here, and quite honestly, here is the closest point. They don't measure any pollution there. But it happens that you will see something like 15 there. That's here is Zurich, for instance, the most polluted place. And you see, if you know typical states from Krakow, you see the difference. So that's the way how you can win a couple of years and devote maybe one of them to learn German. But just a hack. Because maybe it's worth it. So that's a company, CSS Versicherung, insurance. And okay, I won't be talking about myself for long. I will be talking about this. This is the machine I started learning. So who knows this machine? Commodore 64. And I programmed. I won't sing a song about Atari because my voice today is not great, but okay. So this is how programming on Commodore looked like. Like my first weeks, I was programming with BASIC. And you know what? One thing is great about BASIC. If you want to impress colleagues, with BASIC you can just hack something very quickly. Like you hack a couple of lines, you have some nice effect, whatever. I won't show you today great effects because I don't have that much time, but it's really a couple of minutes, and you are done. So for instance, here my intent was, I show you BASIC and I want to greet you somehow. And there is a procedure in line 500. You see already great thing about BASIC. You don't have to invent names. You spare a lot of times because you don't have to invent names of the procedures, of functions. You just have line numbers. How cool, yeah? And then I will want to greet you 3 times. Go sub means call a procedure. Go subroutine. It's simple. So I will greet you 3 times, and we'll see what happens. First time, hello DevOps was what I wanted to do. But then, hello DevOps, what is this? Who knows where is the bug in this code? Come on, you know BASIC. Everybody knows BASIC. Name is global, and that's the problem, and that's the great part of the BASIC. You have everything global, so you don't have to worry. You just can access in every line, every variable, and it's very fast. You save a lot of time until the moment you have bug. But if the program is like 1,000 lines long, you just read all of them, and you see quickly the bug, and you are done, and you are very fast. But there was a moment, maybe 3 weeks after I started programming, when I reached this 1,000 lines of code. And I was starting to do something bigger, and then I realized, oh my God, BASIC isn't that cool anymore. So I was thinking about switching to some other languages. So in the meantime, for instance, I switched to C, because what you have in C language, you have to declare variables. Not every variable is global. It's cool, it solves a lot of problems. So I switched to C, but then I had, after a couple of years, some problems with C, because C was like, oh my God, how to encapsulate things, you have to remember what to call off which function after another, etc. So I read about object-oriented programming, and slowly through C++, I switched to Java, where I'm still. And one thing about Java is great, because In Java, you have encapsulation, object-oriented things, etc. So just take a look at this code. In Java, we have great frameworks that simplify our lives, so that make some things easier. So let's take a look at this code, and maybe I will show you that in my IDE. So, oops. Right here. So I want to write simple service. And this is a REST service. It is done with Spring Boot. I have funny controller where I have under this name hello, I have this method hi. I check for the parameter name who, and then I use this who bin, where I set name and then set time. And then I log something, greetings done, and then I call this give me greetings. So let's just take a look what the who is. Who is this bin? String name, local date time, getters, setters, nothing interesting here. It's funny. So what is the service? Give me greetings simply says greetings, who get name, who get time. Easy. Yeah, so it's like this. If I call this service, so if I restart this with Spring Boot, let's see if it works. Just a moment. Somehow yeah, I am restarting. Da-da-dum, Spring is working. Spring is great. I have everything. So just take a look once again at this who set name, time, logging something, and then give me greetings. It should be obvious what we see on the screen. But if I write here something like who is Devox, then instead of greeting Devox, I see surprise. Who knows why? Just a moment. Let's take a look at this code. We can also, sorry, not this screen. Yeah, once again, maybe I will just println here. I will do it println, system out println. Oh, my keyboard doesn't work anymore today. System out. Yeah. Why are you laughing? So println. Come on. And who? Maybe I switched to pink mode and my keyboard doesn't respond, but that doesn't matter. Okay, I will restart it. Who get name? Okay. Ta-dam, ta-dam. Once again. I call it. Control refresh. Surprise. Okay. And then I go to the Windows. You see, Devox was here, but print is Devox. So the problem is, it's Devox, this is this thing, but then it's surprise. What has happened? So you know what has happened. With this cool framework, it's possible to change Java to basic. Anything can be global. And the thing is that here I have something called logger, where I intended to log a message, but I auto-wired this who. And because I was evil, I set the name to be surprise. How cool. So it's exactly what can you do if you want to be efficient. If you want to be efficient, you do everything globally, and you do a framework that makes it easy for you, which changes Java to basic. It's cool, it works. You can really impress your colleagues, and it works very well unless your program is not longer than 1,000 lines. But because later, you have to look for those things. And you may think it's very artificial joke. You wouldn't see that in production. Yes, exactly such things I find on productive systems. Especially this kind is even my favorite. When somebody works with something which is, so the who is request scoped bin. Who is using request scoped bins? Just raise your hands. Nobody. I don't believe you, because I see this. session scoped beans. All of them are basically global. And basically beans in a typical bean in Spring is just global, singleton ones. Okay, so that's just a beginning of the story. And we'll go further to container dependency injection. So basically you use Java EE or Spring to do dependency injection. Who is using Spring or Java EE to do dependency injection? A lot of you, cool. And then let's take a look at some code. So for instance, this code. This is the user activity logger, something, again, based on some real sample. I inject user repository here. Then I have this method, store activity. I call save, how cool, user ID, action. And then somewhere in the code, I see this new user activity logger, my user store activity log. Who sees the bug here? What? Yeah, null pointer. Why? Yes, you know that because you know if you have inject or something like AutoWire or EJB or whatever, the bean, this class cannot be created with a new. New is kind of forbidden for you. So you learn quickly that all your classes cannot be instantiated by new anymore. They have to be beans. They have to be created as a beans by container. How cool. Though, so we know that new is kind of broken. Then a second problem. Let's take a look at this. This is all something. We have something, scope, request scoped, user activity logger, user repository. So we logging some user activity. But because it's not really important for the moment, it's just some kind of log, maybe we wanted to do it in the background. So we wanted to do it asynchronously. So we call some executor service, and we call this user activity store activity in a task, which will be called asynchronously. Who sees the bug here? Yeah, so basically, if user repository uses some session persistence concept, it would fail. Basically, you learn, while using dependency injection container, you learn, second thing, you cannot use threads, because threads are kind of broken. They don't really work well because your transactions, security context, etc. is broken. How cool. So the third thing you learn is that objects, for instance, who knows post-construct or things like that? Method. What is the post-construct? So you have a constructor, which in object-oriented programming means that after constructing an object, it's useful. Oh no. It has to go through post-construct to be really useful. It's how cool. So we have a life cycle of object which is not as simple as before, constructed and useful, no. Constructed, partially useful, then after post-construct, etc., really useful. How cool. And there are even more, if you look at EJB scopes, it's really crazy what can happen. So the next thing I see in a projects, if you can inject anything anywhere, you will see this example, then quickly you have classes that, for instance, have 15 dependency injections, like AutoWire, AutoWire, AutoWire. So it's really, I see that numbers in the real projects. How cool, because it doesn't cost you anything, you just inject, and then you get a hull. Funny thing about it, if you have a problem, it's like in BASIC. You cannot debug it easily. You have to go to the runtime and just see, oh, there is some of the beans is null. Why? Where you put the debug line to find out why it's null, why it's not injected. The code is not even your code. It's some container. How cool. And that's what I really like in Java. You have getters and setters everywhere, because we love to write such useful code. Getters and setters for the win, and then we have mappers. One day in our company, we had an exercise where we were doing, our task was to find some ugly part of the random code project and refactor it. It's a cool exercise to do. And the funny thing was, 9 out of 10 teams randomly found ugly part of the random project to be mapper, something writing from getters to setters. How cool. Then we realized, okay, maybe 90% of our code are just mappers. And the broken encapsulation, that the problem, yeah, you can inject everything everywhere, you can change any, even though with this who example, name was like private field in some kind of bin. And I wasn't even passing this bin to some service, but this service get this bin injected and could change it. How cool. So, but maybe some of you know, okay, a lot of these problems, like with asynchronous calls, can be solved with just one another annotation. Like if you want to call something asynchronously, there is for sure somewhere annotation in Spring how you call asynchronous task. I've forgotten it for the moment because I'm mixing it with Java EE annotation, which is a little bit different. And there is annotation for everything you want to do. So that's cool. The problem is that's not Java anymore. You don't use new, you don't use threads, you don't use normal JDK, you have to use special, another book, read another book with another language of annotations. How cool. And the thing is that what it really resembles me, like I am doing Java EE and Spring for 17 years. Really started with JBoss 1. How cool. And at that time, the development, maybe you've heard it from your older colleagues, was Java development was in fact XML development. We had these big XML files and everything was configured in XML. And in one moment I've seen, okay, we have annotations. How cool, Java 5 annotations, no XML anymore. How cool. But then I realized, oh my God, this XML is gone. It's just now embedded in Java code. It's called annotation, but it's the same XML. I'm writing in the second language, which is not really Java. Okay. So is there any solution for that? Because I'm bashing something that's really, most of you write with that. So if you look carefully, there is one great post from Oliver Gierke done a couple of years ago about field injection being evil. Who knows this? Great. So he just simply said, if you have this code, like inject my collaborator, then this code is basically surely wrong. Because it might work, but it's like begging for null pointer exception. Because where do you put debug line? How can you check that the bin was injected? So he proposes that we should write always container-based injections, so like with this inject my component collaborator. It's a little bit different. It's better, for sure. I do agree it's way better. Right now, we can put somewhere our constructor. We can put assertion. And in this post, Oliver Gierke is one of the authors of Spring. You see that this constructor-based dependency injection means better testability. Yes, you can simply create in test this class without Spring context. You see, if you have too many dependency injections, in one moment you see, oh my God, my constructor has 6 fields. So it's the moment where you start refactoring, not in the moment you have 15 and it's too late. So it's cool. It's way better encapsulation because after construction you have really useful bin. Typically you don't need post-construct that much. So there is this great post, why field injection is evil. I do recommend it. It's quick, it's small and it's great. But I think we can do better. Like this. You see it's like on this Oliver Gierke post, but with one difference, there is not this inject. There is missing this inject, and it's better. Because then it's completely plain Java. It works all the time, without Spring context. It's just compiler, which is proven to works. It works with a keyword new perfectly. And maybe some of you, okay, but what if I have these 6 dependency injections? Like there was a post on some Polish forum called For Programmers Net, which is like Polish version of Stack Overflow. And one guy presented me this sample, magic service, and then how many injections? 6 injections. And he said, oh, come on, how would you write it without Spring? Well, who knows how to solve this problem? What? Exactly, because the answer is not how to write it differently with something else without Spring. The answer is how can you write that bad code? If you know something about clean code, the first thing you see, oh my God, for sure, this class breaks single responsibility principle. It does too many things. So In fact, I presented some longer solution to this problem in many steps. I refactored this code to be this magic service to be like depending on 3 or even 2 different dependencies. And then some dependencies split it. Exactly. This class became 6 or 7 classes. And that's the correct solution to the problem, not just another dependency injection. But this is easy. I would say simple Java solution. But sometimes the life is more complicated. So there are some patterns that solve you the dependency injection problem. So one of the patterns is, for instance, cake pattern. Who has heard about cake pattern? That's something popular in Scala. Surprise is you can use it even with Java. It's not that nice in Java, but it works. So basically, I don't have enough time to present you this, but the trick is to use default methods interfaces. For instance, user service component with user repository components is something where I have get user service with default implementation. And then at the end, I can create different interfaces like local user repository component with local authentication, or Mongo user repository component with Mongo authentication. That's interface with default methods. And then at the end, I can, for instance, create instantiate final classes with and create them with just chosen dependencies, which set of dependencies I am using. So for tests, for real production, etc. This cake pattern is quite productive in Scala. In Java is a little bit verbose, but still works. Maybe you have different problem, like you have couple of classes and you don't really know, you don't want to care which to instantiate first, which second. There is a great pattern for that, lazy container. It's who is using Java slang or Vavr now. That's a great library. I would say that's the first library in Java that you should use. It's better, for instance, than Java util collection, etc. for most of the problems that you have. And there is this lazy container, which means, for instance, I can use I can create couple of services, and maybe this service one I am even instantiating first, but finally it will be constructed later after service 2 is instantiated. How cool. But more, I would say that my solution to most of the problems is doing simple Java, like this thing. Maybe, so just to show you, this is user service. That's the code you can find on my GitHub. I will be showing this code, in fact, later today on the other session about Ratpack. And I have user service with 2 dependencies. I'm doing something. And then I create some supplementary class. I typically call it module. That's my pattern. That's my convention. In this module, I say, for instance, that the default implementation of the user service is with these 2 dependencies. But if I am writing unit test and I don't want the real database or things like that, then I'm using this constructor. It's easy and it works. And you don't need any magic container. You just use Java and constructor and compiler. Everything is proven to work all the time. And if it's broken, compiler will tell you that, not a runtime. So basically, that's my message to you, that compiler is great. So, but then you can make question, if you try to do it with JAX-RS or servlets, you will see that, oh my God, life is not that nice. Why? Because servlets have one problem. Servlets or whatever you write with Tomcat, WebSphere, JBoss, you write the classes that are already instantiated by some container. You can't avoid that. And this is the problem. If you have a servlet that's already instantiated by something else, you cannot, how to call it, you cannot really influence this instantiation. Then you have a problem. But there is a solution to that. My answer to that is forget about servlets. Today I have session about Java web server called Ratpack. Who had heard about Node.js? So it's a JavaScript server which people really, in small teams, hack things and they have real working services. And they don't do over-engineering. They do it quickly. And I've seen a lot of Java guys being jealous. How could they do that so quickly? And why this thing works so fast? So you don't need Node.js for that. You only thing you need is how to call it, the common sense, and use Java. And there is this server called Ratpack, where you don't rely on servlet specification, which I simply say is outdated. You shouldn't use it in 2017 because it's answering the problems of 90s. So that's a Ratpack. How you create a servlet with Ratpack? You start this with a main method. How cool. You just start main. Then you call Ratpack with some configuration, maybe with one thread. That's cool. You can create a web server in Java that is using one thread, which is cool. I will tell you on the second session today why it's cool. Of course, you can use more threads, like 4, like 8, but you wouldn't use like hundreds of them. There is a reason, performance. And maybe I'm here constructing the Fibonacci server. So under the prefix Fibbo with parameter n, I am calling this Fibbo handler, and then I am calling this real Fibonacci. What is great about Ratpack is testing. That's the cool stuff if you do plain Java. Testing is easy. Because who has tested any enterprise use, Java EE or Spring Code with, for instance, database? How do you test that? Is it easy? It's horrible. Or how do you test REST services? How do you test if your REST service works? With mocks. I will address this later. But this time, how to test REST service? The best way to test REST service is to test REST service. And it looks like this. I create a server, and exactly that's the method I created here. So I start my server here in the test method. Then I'm using test HTTP client. I'm using HTTP client. I'm really calling this. That's a real call over the network. And I check if the body responds to what I wanted. It's as expected. And some of you may say, oh my God, how heavy test is that? How much time do you think takes to start Ratpack server with configuration? Who knows? 10 seconds? Who is for 10 seconds? 5 seconds? How much? 50? Less than 50 milliseconds. Give me numbers. Okay, this server, okay, it depends, of course, on the machine, but it's around 10 milliseconds. It means you can start 100 such servers per second. Start and stop them and test them. How cool. So really, and then you really test what is working on your production, not some mocks. What about what? I haven't understood the word. Yeah, you can start in tests of Ratpack. I will show you later. You can, for instance, overwrite. Use different port, or you can for sure start them one by one. So they start on the same time, on the same port every time, but the previous one is closed before you start the next one. Okay. But if some of you, I'm working for the insurances in Switzerland. I have WebSphere. Oh my God. And I cannot drop it. I have to live with that. But my team, in fact, has found a solution, because when you have problem, you build a wall. You know, that's the common world solution. Just build a wall. And our wall in Java EE is like this. We have some beans. We have to use EJBs. Just we are forced. And then those EJBs have persistence context with entity manager. So similar story is in Spring, whatever. But what we then do is we don't really code inside of beans. We call this, that's our name convention. We create delegate classes. What is delegate class? It's basically mirroring the bean, but it's a plain Java class. It's not a bean. It's not broken. It's just Java class. And it has entity manager as dependency injection. And we are clearly constructing this class here. And it's even more, if this class is maybe using database, and then this class is using some maybe real calculation, some logic. Then we write this logic in the third class, where we have plain Java logic. that we can, for instance, test. So we have in this myCalculator class where it's plain without database logic, we would do our business logic, we would write test for that, what our business wants. Then in a delegate, we would have this plus real databases, things like that. And then finally, only the wrapper, only the color of this inside of EJB. What it means for us, that we have very well tested this part. We have slow tests because they use database, but in-memory database, but they are still slow with the for the service delegates. And finally, quite honestly, we don't have those tests for these wrappers because first, this class is trivial. Second, testing that with a real container is just ugly. But we've solved the problem. And this pattern, it works pretty well for us. So it's not really the clean architecture as proposed by Uncle Bob, but I would say this is exactly our what influences us. What's our motivation? Write clean business logic in clean Java without any machinery, without any magic. So you can, for instance, put it inside Spring project, inside EJB project, or inside plain Java project. It should work. Then you can, on top of that, you use some nasty frameworks, but not inside of that. That's the core point. So does it mean that all inject EJB auto-wired are bad? I wouldn't say so. If you are doing some plugins, or you have customizable deployment. So it means for this customer, I'm using this jar with these dependencies. For other customer, different jar. Then usage of such annotation is perfectly legal. If you have remote calls of EJB, by the way, you know that EJB, this original Java EE, was done in order to make remote calls. That was the motivation to do that. It's only then stupid that we do EJBs inside of a project that don't have anything remotely. Yeah, it's just misuse. But okay, so if you use that annotations for these reasons, then it's completely legal and find it useful, yeah? So every time you use something, your compiler cannot help you in that. And now another story. So I found a great book in French, but it's translated, which describes things that young boys do. And they then have these symptoms, these tumescence of stomach, digestions, yeah, vomiting. You know who has these symptoms? None of you will say, but there is even a great picture to that, how typical boy looks like. There are a lot of such pictures in this book. You know what I'm talking about? Whom? I'm talking about mockists. Really, young boys and girls do that, where we don't watch. So that's a sample I found on the net. One guy asked simply, he created his first Spring project. That was a beginner. First Spring project. And then he asked for, how to call it, review. And then he showed his tests. So that's a great test. So he has something called flashcard service, where he had method findAll, and where he is using flashcard repository. Just take a look at it. Flashcard service, flashcard repository, method findAll. That's the service. And then the test of it. That was probably the best test I've ever seen. Oh, quite honestly not, but one of the best. Should find all flashcards. When flashcard service find all, then return get flashcards. Flashcard service find all, and then assert. You know, what's great about this test? It's a perfect test for every developer and his managers. It will never fail. It will be always green, no matter what you have in your implementation. Can you do better tests? Absolutely not. It's not possible. And you may laugh, okay, that's just a mistake of a beginner. No. I see such tests quite often in a productive system. It's even so, we had a big system written with Spring, by some external company, which they wanted really to cover everything, 100%, but they wanted to do it cheaply. So they've written a lot of such tests. It was great because I was doing, for instance, refactoring. I've seen, okay, oh my God, it's all tested, how cool. So I maybe, for the first time, I just delete all the code. Tests are green, how cool. Done. So it's really what happens if you overuse Mockito a lot. So I don't say, by the way, that those tests are useless. Those are great tests for Mockito. So every time you write such test, send greeting to Szczepan, who is the author of Mockito. You tested his framework for the millions times. So that's great. And a lot of companies are doing that, really. There is even something called London School of Test-Driven Development. Who has heard about it? Like, you simply mock everything. You just, after every line, you check if the response of some other service is, you verify if it's exactly what you would want to write. So the problem is with this school, just take a look at it. There are articles. There is the problem that you test mocks only. And Mockito is the most tested. And there is even the best problem. If you can use verify in Mockito, then you really test. It was this method called first, then this, then this. So really test everything when inside the implementation. How cool? Because then comes the day, I'm doing refactoring. I'm trying to change something, just split something. And oh my God, I haven't even really changed the logic, but tests are broken because I'm doing something in different order. So really, is it, even though the method returns the same result, my test says it's broken because it's doing it in a different, for instance, order. So what's the point of having such tests? So because why we write tests? We write tests so that we can do refactoring easier. But if we have, every time we have such tests with London School of TDD, after refactoring, we have instantly to change the tests, something I think doesn't really work here well. Just think about it. OK, when mocking is really good. So I say there is one place where mocking is perfectly OK. If you test against external systems, something that doesn't belong to you. But if you mock your own classes, I don't say it's always bad. It's often OK, but be careful. Because maybe you will just test only mocks. And then comes the question, is a database external system? Who thinks you should test with a database? Who thinks you shouldn't test database, you should mock repository? So I raised twice hand. Why? Because it really depends. If your contract is just register this user somewhere and later on check if somebody logs in with this user account, he should be able, because it's somewhere persisted, and you created the schema of the database on your own. You are the responsible for this. None else, nobody else. Then the database is your internal part. It's your internal tool, and you are supposed to test that. But if somebody says, that's our database, it's company-wide, it has these tables, you should read from those tables, then store inside another tables, then it's external system. And you even should mock it, because to check that your logic, for instance, still works, even though somebody changed something in the database. So it's very simple. Is it your or not? And then you mock it or not. OK. Then comes the question of aspects. Who knows this thing? Pre-authorized, post-filter, transactional. Who thinks it's cool? Because I have all my transactions problems solved with this transactional annotation. How cool. I have annotation for security, everything. Then, even better, you can write your own aspects, like this. How cool is that? So I have Java, I have types, classes, and then I write aspect, and all I can use is object. It's real object-oriented programming. All arguments are object, or classes are object. Cool. That's the point. But OK, the thing is, can it be better? Because if we look at aspects, there are a lot of aspects: transaction, cache, validation. And typically, I see in enterprise systems, those are annotations to solve those problems. Can it be done better? So take a look at it. Maybe post filter has permission. Really makes sense. So what's this? I say, is it Java? Is it declarative thing? Because people say it's not really declarative. Come on. What is that? This is the pathetic stringly typed programming. So your real logic is in strings. It's really like that. And you can do better. And there is, for instance, this is from my sample application somewhere else. If you want to use database transaction, what can you do? You can really program that in kind of generic way. Like here I am creating session, open session. I begin transaction, and here I call something like db command. And db command is my parameter, a function. Then I commit transaction, and in that case, maybe I had constant violation, and I wanted to retry transaction. How cool. Try to do retrial with annotations on JPA. It's horrible. But if you want such a method that will just retry your transaction automatically, you can write it. And then, how to use that? Instead of writing here transactional, I just call it this, do transaction, and that's my method. Session save, I have everything. So this is the functional approach. I changed annotation to first order function. Really, it's easy. It's easy pattern. And maybe you say, oh my God, writing that method is just insecure. Maybe I will do a mistake. You don't have to write them because there are guys that written them for you. So there is a great Juke library, and the author of this, for instance, had created. Create transaction exactly makes that, and here everything you do is inside of transaction, and you have access to this transaction through txconf. It's great. It's functional way of solving aspect problem. The same thing you can do with, for instance, security. Like maybe you would have one public method doSecure, which takes HTTP request, permissions that you want, and then the final action that you would really want to call inside of secure request. And then you use it very simply. doSecure with this HTTP request, I need permission write, and then system checks everything, and then finally does what you want, maybe DB service write. And then you can simply rewrite all those aspects, all those transactions to the functions. And yeah, that is even better because you can compose function, and functions work in compiler. Functions work perfectly inside tests. You can test them, you can debug them perfectly. You don't rely on any external engine. By the way, there are good annotations. So like override, functional interface, immutable, nullable, not null. Do you think not null is a good annotation? Who thinks it's good? Raise hands. Who thinks it's good? Okay, so the thing is, when would you use null? In 2017. In Java, the answer is almost never. So if almost no field can be nullable in your Java code, it means, oh, come on, you should not mark every field and every argument not null. Just forget it. Not null is a default in Java. You shouldn't just use null. Maybe with some exception, you work with old code, just use nullable. And then test, dynamic test. Those all annotations have one thing in common. They help compiler, then help you to check that your code is better. Then there are just some marks to compiler. There are compile build time checks, yeah, like this. And there are other sets of transactions like this, JSON deserialize, JSON create, or XML root. Those help to convert something from Java to JSON, XML. There are different such annotations. Again, this is Java, non-Java collaboration. And by the way, I don't think those are perfect because, for instance, in Scala world, they already changed this approach. So in Scala, it's possible to do JSON, for instance, mapping without annotations, well, on a compiler level. It's way better, I would say, but in Java, we don't have that good stuff like compile time macros. Okay, because you know, when something is done by the compiler, it's proven under compile time, not under runtime. So if you have problem, for instance, JSON mapping is just basically broken, cannot be, you would see that on the compile time in Scala, not on the runtime. This is one thing I like. So I'm reading some historical books and texts. And if you look at the medieval texts, like the charters, treaties, or pacts, you would see that typical look like this. John, by the grace of God, King of England, Lord of Ireland, Duke of Normandy, blah, 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 blah. It's a lot of that. And it's even more, know that before God, for the help of our soul and those of our ancestors, blah, 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 blah. You know, it's really funny because this text is long. You know, this is a famous text. You know, who knows this text? Okay, this is something called Magna Carta. It's one of the most known English charters. So, nevertheless, after such many preamble, this great text in the introduction, finally comes the core, what he is really wanted to say to us. This is the core, the yellow one. The problem is, then again, blah, blah, something, and then this text looks like this, and it's really hard to find the real content inside of that. That's the problem. And the thing is that I realized one day that some of the Java developers are really greatly, influenced by these medieval texts. That's the class. Unfortunately, I cannot show you the code. It's secret. But basically, in this code, minified, until this moment, we have preamble. We have annotations, really. That's annotation up to this point, and here starts the class. It's almost 60% is annotations. How cool. And you know what kind of framework in Java creates this? JPA. It's the best thing. So typically it looks like this. I've seen it, hundreds of times. Named query. It's not even named query. Cacheable, blah, 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 read-only, etc. And then finally starts the entity, which is just such small. And then it's funny because if you have a problem in one of these annotations, how do you check by the compiler? It's only while you start the container, maybe some of those selects are really scanned, and you see the problem. So, okay, that's JPA. So I would say for you, JPA is not really good framework for typical business applications that you'd write with Java. Why? Because there are a lot of problems with JPA. The annotation is only one of them. The problem I see typically is that really regular developers know SQL. They know SQL. The problem is they have problem transfer it to JPA query language. Transfer SQL tables to mappings in Hibernate, JPA, whatever. The life cycle of JPA is very complicated of entities. Like you have detached, managed, etc. And for instance, my best thing, the best bugs, sometimes Heisenberg bugs on production is where somebody has nested transaction, requires new. And inside of requires new, he creates an object, persists an object. And then this object is returned to the external transaction and attached to some list. JPA really gets crazy when it finds it. So Hibernate, whatever. So there are a lot of problems with that, but there are easy solutions. Just forget about JPA. JPA has some uses, but there are better libraries, I would say, for you, like Juk or MyBatis, which are very simple. And if you talk SQL, you understand SQL, you can really use the full power of that with, for instance, Juk or MyBatis. Really, years ago, first time I've seen MyBatis, I was lucky. Oh my God, how primitive is that? But then I've seen that the project was really working well because we were not spending weeks trying to find out what's going on, why is null there or whatever, because we had everything just written in code. It's cool. It's no magic, no SQL, and we talk SQL like human beings. Okay, so I'm going to end this talk. So I've shown you a lot of problems with annotations. I'm showing you some good examples how to get out of this hell with, for instance, functional code or compiler. There are resources you can read about. It's like Oliver Gierke I mentioned. One great presentation is from Mario Fusco is Gang of 4 Patterns to Lambda. So how to, lot of patterns that you use that maybe you learn in studies are just outdated because of functional programming. You can write them way simpler with just functions. Unconvoke made a post about dependency injection inversion, which he also says about why to use container to do that. Annotation Mania is a great page where you simply, where they are just bashing annotations. Just recommend to take a look at it because author is this is the author of Juk is posting very funny things about it. So Technology Radar, who knows Technology Radar? So it's a great page, and years ago they published, you should stop using application servers. It's now 90s are gone. Come on. So it means also servlets, etc. forget about it. Okay, they propose different solution. You can use embedded servers, but I would say there is even better thing as embedded server. Things like Ratpack, for instance. If you want to see the clean application really working, I will be showing it in a couple of hours. It's Ratpong. It's on a GitHub. You can look for the Ratpong. It's a Pong game, web-based Pong game, done this clean way, without any annotation, containers, just plain Java. And you see that the code really looks nice. And about annotation, I would say once they were really great, and I was really happy to avoid XML and start with annotations. But then, after years, I realized they bring another problems. And those problems can be solved with lambdas way better. And we should give our chance to compiler, because compiler is proven to work all the time. If it says something is broken, then it's broken. If it works, it should work. So give chance to compiler. Okay, Switzerland is the thing. Tests. If compiler doesn't help you, then write tests. And only then, if test and compiler doesn't help you, the reflection or this magic of container is your last resource. But you should use it not that eagerly as you do it probably now. You should do it as a last chance if anything else doesn't work. Yeah. And by the way, using that, you can really make Java great and funny again. You can do nice projects, not often engineered. Yeah, great Java. So that's all I wanted to say. Thank you very much. Unfortunately.